Okay, so for this guy, we got three graphs. Okay, we have the square root of x, x equals 9, and the x-axis. Okay. So, order doesn't matter. You can do whichever one you want first. Square root of x, x equals 9, and then the y-axis. The y-axis, its other name, which the calculator recognizes, is y equals 0. Okay?
The x-axis?
Is that the x-axis?
And the x-axis.
And the x-axis, right?
Yeah.
Yeah. That is the x-axis, isn't it? Y equals 0?
Oh, you said, my bad, you said the
Did I say y? Yeah.
y-axis. I was like, what?
Yeah, don't listen to me. Okay, there we go. There's our picture here. Okay? So sketch that picture, if you haven't already, onto your notes. We'll start there. So along with the graphs, you see the words cross-sections, cross-sections. That means they want us to use the cross-section method, which is what we're going to do today. Okay? So, again, bounded, so we're going to shade. Anytime it says bounded, that's the part you're going to shade. So the bounded area looks like is here. Here's where it's different. It's not going to revolve around anything, right? It's not revolving around anything. That was disk and washer. It's not going to revolve around the X or revolve around the Y or revolve around anything. It's not going to, okay? So we have the red on mine is Y equals square root of X. The green on mine is Y equals 0. And then the blue is X equals 9. Okay? All right. Cross sections. So since it doesn't revolve, how are we going to build, or how is the thing built? It lays on top. It lays on top. So for this one, it's going to be squares. All right? It's going to be squares. How do I find area of a square?
X squared.
X squared, S squared, X times Y, whatever you want, right? All sides are the same, right? So we know for a square, all four sides are exactly the same. All four sides are exactly the same, right? Okay, so what's going to happen now? So this is part you got to kind of visualize in your head. What we're essentially going to do here, mathematically, is take a bunch of squares, right, and make them sit on top going perpendicular to the x-axis, right? So let me get a piece of paper here. Okay, so I'm going to make a square, try to make some sort of square. All right, so here's a square here. These squares are going to sit on top, and they're going to be perpendicular to the x, right? So the x is here. That means they're going to sit here. So this is a little big. So it's going to, one edge is going to sit on that line there, the red. The other edge is going to sit on the green. And they're going to sit. Obviously, these squares here are going to be smaller because the distance is not as much than these squares over here, right? So that you're going to have a bunch of squares sitting here, all together, smashed together to make a shape. What is the shape? I don't care. That's not really what we're asking here. But that's essentially what's going to happen. Okay? Okay, so each square is going to sit from here to here. That's a side. So that's going to be one side of a square. So it's going to be, we'll say this side. Right? And it's going to stand up. So the square will be kind of standing up here. And there's going to be an infinite number of other squares that smash together to make a 3D. So the 3D shape, this is the bottom of the 3D shape. It's going to be up, they're going to be up like that. Okay? That's what we're doing. Okay. All right, so now, since it's perpendicular to the x, we're going to be a dx. It's going to be a dx situation, right? Okay. So let's set up our formula. Volume equals. Notice there's no pi in the beginning. Why is there no pi?
Because it's not.
There's no square, there's no circles, right? There's no circles here. We don't have any circles like we did for disk and washer. Okay?
X squared?
So yeah, so we're going to say, so let's start with the area of the cross section. The area is x squared, right? So all I got to do is find one side, right? Each side is x. All I got to do is find one side and square. Here's a problem though. We just said, if I were to kind of move this line, right? It would get longer over here and it would get shorter over here, right? So the squares are different lengths depending on where they're at. Over here they're a little shorter, then they get longer, then they get bigger, right? Squares is bigger, bigger squares, right? So how can we do it taking all that into account? We'll use the function. We'll use the function. So how big is this side going to be? Well, it goes from the red to the yellow, right? Or to the green. It goes from the red to the green, right? Well, what's the y value? How would I find the y value at that dot there?
Is the function?
I would plug it into the function, right? How would I find the y value here?
Plug
Plug
it in the function.
it into the function, it's always going to be 0, right? And then I would do what? I have two y values, and then what would I do? So I have the y value here, I have the y value here. How would I find the distance between them? Subtract them. That's what we're going to do. That's what we're going to do. I'm going to take the function of the red minus the function of the green and square it. Whatever that distance is, that's what our side would be. And then we're going to square it. Why do we square it? Because that's the formula, right? Side squared, x squared, whatever you want to think about it. Okay? The bounds. The left bound, x value to the right bound.
0 to 9.
0 to 9. Yep, right there. 0 to 9. Then calculator. What do you get when you put it into the calculator? Mm-hmm. 40.5. You should get 40 points. So the volume of that shape is 40.5. Mm-hmm. Yeah, go ahead. Let me get you a pass. Hold on one second. Go for it. Okay.
Just what we did before. Not like before this lesson, but haven't we done this?
I don't know. It's a good question. Might have. Yeah. Okay. So now, let's go to B. B is exactly the same graph. So redraw that graph. Redraw your graph because it's exactly the same. The only difference is it's not squares, it's semicircles. So redraw, so take a minute to redraw the graph because it's the same thing. It's the same three graphs. Actually, you know what? I'm not ready to write that. Okay. And then the shaded area is the same, right? Everything about it is the same. The only difference is what shape is the cross section. Okay. This is a semicircle. Yeah, this one's a semicircle. So we know our formula says we have to find the area of that cross section. So it's going to be an area of a semicircle. So what is the formula for area of a semicircle?
Pi times radius squared divided by 2.
There you go. Right? Semicircle is just half a circle. Right? So area equals pi times radius squared divided by 2, or 1/2 times that, right? So that's the formula that's going to go in here because it's a dx, because it's perpendicular to the x. Okay? So the semicircles are going to sit on top of that, and they're sitting perpendicular to the x. So they're going to sit the same way the squares did. Except instead of having a square, you're going to have a semicircle. Okay, so it's going to be like curved. It'll be curved. Kind of look like a loaf of bread, kind of. Like a tapered off loaf of bread. Okay? All right, so this is the side that's going to sit. The flat side of is going to sit the same way the squares did. So imagine if I had a two-dimensional half circle and I made those dots go right on top of there, so it's standing up. Okay, that's what it's going to look like. And then you're going to have literally an infinite number of those smashed together to make that 3D shape. Okay, that's what it's going to look like. Again, not important, but helpful. It could be helpful. Okay. All right, so if dot to dot is this here, what do we call that length? Not the radius, you're close. It's actually the diameter, right? Because the radius goes here to there, right? So this is actually the diameter. But what do we know? Diameter, is that in our equation or in our formula anywhere? No, so we're going to have to tweak it. We're going to have to tweak it. So right now it says R, right? I don't want R, I want D. What's the relationship between D, diameter, and radius?
It's just
Pi
r.
times pi.
No.
It's just 2 r's.
Yep, 2R, right? Well, I don't have any D's in there, I have R's. So how can I solve for R?
Replace r with d.
Divided by 2. Radius equals the diameter divided by 2, right? So what I'm going to do here is I'm going to rewrite the formula that I had earlier. But I'm going to plug this guy in for R. Because it's the same thing. Isn't the radius the same thing as the diameter squared, or half the diameter? So the new formula is going to be this. Pi times, instead of R, I'm going to have D divided by 2 squared. Over 2. What is D over 2 squared? What is that simplified? D squared over 4, right? Simplify even further, right? Instead of dividing by 2, multiply by 1/2. What is the finished formula?
Pi times d squared over 4 times 1/2.
Which is 8, right? That is the area. That is the area formula we're going to use. We can't use R's. How come I can't use R's? Because I don't know what R is. I don't know. it's a sliding scale. This diameter is going to change. It's never going to be the same. So to use that, I have to tweak it a little bit. Okay, so that's the equation, that's the formula I'm going to use. So down here when I do some volume stuff, that's the guy I'm going to put in there. Okay. That's where this can get a little tricky, that part there, that kind of thing there.
Pi times the square root of x.
Okay, so now let's put it in. Pi times, right? Pi times 8 on the bottom. This guy's squared, right? What is this guy going to be? How do we find the length of the diameter? Just like we found the length.
Top end minus the bottom.
There you go. Just like we found the length of the square, right? Top function minus the bottom function, right? Top function is square root of x. Bottom function is 0.
So it's just the square root of x squared.
So it's just going to be the square root of x minus 0 or the square root of x squared, which is just x, right? Are the bounds going to be the same, going to be different at all?
Nope.
0 to 9, right? So again, when you put it into your calculator, I would try to simplify it a little bit. So you're going to get pi times x over 8 dx.
And then do you square the outside too, or no?
No, because the only thing that's squared was d, right?
Alright.
Yeah, the only thing that's squared, that's another difference from disk and washer, right?
I got 15.9.
Yes, 15.904. 15.904. Okay. So the reason we did all that, I didn't want an R. I don't know what R is. I just know what D is. So I had to manipulate it so that instead of R's, I had D's. So all I did was substitute. I know that radius is the diameter divided by 2. So I plugged it in there instead of R. Same thing.
Can I go back to him?
Yeah, go ahead. Let me get you pass. Okay. All right, so that's for semicircles. Now, this should be example 3. I don't know why they're all example 1. That's weird. It should be.
Because they're all the same one, it's just.
Oh, yeah, you're right. Yeah, because it's just ABC. Yeah, ABC is changing. Yep, you're right. All right, so C is a right triangle now. Okay, don't worry about that part. Sketch a picture. Sketch a picture real quick. It's the same picture you had before. This is the last one with the same picture. The next problem, we change it. So the base means where it's going to sit on top. It's perpendicular to the x, so it's still the x. The base is going to sit here. So one side's going to go up and then kind of come down. So I'll draw you a picture. So isosceles means 2 of the sides are the same. Okay. So okay. So we have this side. So right, one of the legs, right? The legs. So the right angle is here. The right angle is there. You got the 2 legs that make up the 90 degrees, the side. The 2 legs are here, and then the long side is the hypotenuse. So one of these legs is going to sit there like we did the last time. So that's this over here. That's going to sit right here. Because again, it's got to be perpendicular to the x-axis. So that side is going to, so it's sticking up and then down. So that the triangle's kind of like that. Triangle's going up like that and then down here. Okay. Area of a triangle. What is the area of a triangle?
Base times height divided by
Base times height divided by 2, right? Okay, let's see. So I need a base and a height for this guy. What's true about the base and the height?
They equal the same.
Because they're both the legs, right? If the base is sitting here, that's going to be the base, and then the height is going to be exactly the same, right? It's half of a, it's a diagonal cut of a square. So base and the height are the same, right? So
Can it just be base squared?
it could be base squared, it could be x squared. Yeah, if you call this side x, then it would just be x squared, right? So either way you want to think of it, go for it. So volume equals dx because it's perpendicular. Bounds are the same because it's the same graph and it's dx, right? 0 to 9. So what's the base going to be?
This is square root of x minus 0.
Square root of x minus 0, right? The square root of x minus 0. So we have the square root of x minus 0. What's the height going to be?
Square root of x minus
The same thing, right? So in other words, we have 0 to 9 square root of x times the square root of x. What is the square root of x times the square root of x?
x.
X, yeah. So it's x over, it's really just x over 2. Calculator time.
20.25.
Verify, you can get 20 and a quarter, 20.25. Okay, so we've done 3 different shapes. Rectangles, or sorry, we didn't do rectangles, we did squares, we did half circles, and we did reached to triangles, right triangles, okay? All right, so now we're gonna change it up a little bit. Well, obviously it's a different graph, right? So the first thing is draw your graph. So draw a picture, y equals 9 and y equals x squared. And then it's gonna be perpendicular to the y-axis. And we go back to a square. So draw a quick picture using calculator or whatever, however you preferred method is to get yourself a picture.
Mr. Fuzz,
Yeah.
why do you think it is that squares are, that rectangles are squares, but squares aren't rectangles?
Go ahead. Yeah, you're good. Go ahead. All right, so what do we got here? X squared. Y equals 9. And that's it. And then we have perpendicular to the y-axis. So you can graph the y-axis. It's going to look like this. Okay. Okay, so the bounded area is inside the parabola. Okay, so we got y equals 9. And then we got y equals x squared, right? Okay. All right, there's our picture. So besides a different picture, How is this also different from,
It's y, it's dy rather than dx.
right? So the squares are going to be sitting not like this. They're going to be sitting like that. Okay, yeah. They're going to be sitting the opposite direction. So it's dy, yep, dy. So remember, we know a square. Right, x squared, whatever you want to think of it, a equals x squared. So this side, or one of the sides I should say, is going to sit perpendicularly to the y-axis, right? So perpendicularly, is it going to be horizontal or vertical? Horizontal, right? Horizontal. So it's got to cover all of the blue horizontally. Gosh, it's Friday. Okay. So it's got to go from here to here. Right? That's where it's got to go. So they're all going to be sitting like that. Okay. Here's my question. How do we do this if it's just red minus red? If I want to find the length, right, is it red minus red? That's 0 length. How do we do?
One of them's positive, one of them's negative, so then you just add the negative.
There you go. Even before that. So one of them's going to be positive, one of them's going to be negative. What have we kind of skipped over? What have I skipped over that's important for this problem? What goes in here, though?
The equation.
Not exactly, but what goes in here because it's,
Oh, y.
there you go, right? So I have to solve everything. I have to solve y equals x squared in terms of y.
Y
That's the first thing, right?
square root of y.
And we've done that before. It's just the square root of y, right? It's just the square root of y. We have a positive and a negative, right?
The left one's negative, the right.
There you go, right? So where is x positive? To the right over here. So the positive x squared or square root, positive square root x, negative square root x, right? I got that by doing y equals x squared, took the square root, x equals plus or minus square root y, right?
You do y equals plus or minus the square root of x to the right.
Yes, I did it. Yep. I did the wrong. So x equals y, x equals y. Okay. So the red function on each side is actually different. Okay. All right, let's go area here. Area equals, or sorry, not area, volume. Volume is, this one's going to be squared, since it's side squared, right? X squared, the area. This is dy. So if I want to find the length, I'm going to go square root of y minus negative square root y, right? Which is really just plus, right? So 2 square root y. What are the bounds here?
0 to 9.
0 to 9, yeah, because we go top to bottom. Only the y values, so y equals 9 to y equals 0. Once you do that, put it in your calculator. Remember, don't worry about y's and x's in your calculator. You can use whatever letter you want to use.
162.
Yeah, it's going to be an even number. I was going to say it's going to be no decimal number. What'd you get, 162?
Yeah.
Okay, we're gonna do one more. Wait, let's see. Do you guys have questions on yesterday's practice? Is there questions you guys have? Is there any questions? Okay, so we'll do one more and then we'll pause for today.
Wait, Mr. Flores, I got a different answer.
One-
I got 81.
Oh, you got half of it?
D squared.
Huh?
D squared.
Does it? Okay, never mind, sorry.
Got it?
I'm done.
That's all right. Okay, so this guy's the same one. Same picture, semicircles this time. Semicircles this time. Okay, last one we'll do today, and then we'll finish the rest on Monday.
Use what we already know from the last question.
So yeah, we've done semicircles, and we just did a dy problem, right? This is another dy problem. So it's going to be the same.
Pi times d squared over x.
Yep.
Over 8.
All right, that's all repeating. We know it's dy since it's perpendicular to the y-axis. Okay. Remember, semicircles are half circles. So pi r squared area equals pi times r squared divided by 2. That's the formula. But we discovered with semicircles, I don't know, right? I got to go, this is going to be the length from edge to edge won't be a radius. It's going to be a diameter.
Yikes.
But didn't I already, we know that radius equals d divided by 2, right? We already did all that mess. So why do it again? You can if you want, but what was the area formula that we came up with? It was pi
Pi times the d squared.
over 8, right? Over 8. We did that already, so why do it again?
Will we use that formula for all the semicircles?
Yes, for all semicircles, yeah. I don't think there's ever going to be a one where they give you r. Yeah, because it's got to go side to side, extend from edge to edge. Yep. So anytime it's semicircles, that's the area formula you're going to use, yeah. For this, for cross sections, yeah. Okay. So we got volume equals, same bounds, 0 to 9. dy. So now I just got to put into my formula, I have to put what the diameter is. The diameter goes from positive square root y to negative square root y. So you're just going to plus it.
Then couldn't you just simplify that to pi times 162 over 8?
Yep. So it would be pi, that would be 2, would be 4y. So really this simplifies because you can add the square root of y and the square root of y to make 2 square root of y. And then you square it to make 4y because you square a square root, it would be y.
But don't we already know what that number is? The square root of y plus the square root of y.
Oh, yeah. Mm-hmm.
I got 63.617.
Yep, that's what I got. 63.617, yep. Okay. That's essentially what we're doing. On Monday, we're just going to go over some more practice. So the last couple questions, example 3 is a different problem using squares. And then the last example, example 4, that is an old that's an old test question that I used to use. That's the FRQ I used from this chapter test. That was the one I used. So I stopped using it a few years ago, so I put it on the notes because it's a great question. It's got 3 parts to it, just like a normal FRQ does. Okay? So any questions? So we'll stop there for today. Any questions on the practice from yesterday?